Good morning everyone. Myself Mynavathi, Assistant Professor, Department of Mathematics from KSA College of Arts and Science for Women, Trichangoor. Now we will discuss the differential geometry. First we will discuss space curve. What is a space curve? Space curve is a curve in three-dimensional Euclidean space defined by the vector function. The function is r of t is equal to x of t I vector plus y of t j vector plus z of k vector, where x, y and z are continuous function. T is a parameter value. The curve can be expressed parametrically as x of t, y of t and z of t. Next one is arc length. What is the arc length? The arc length of a space curve from a point A to B is given by S is equal to integral A to B modulus r of t into dt. When a curve is parameterized by a arc length, the absolute value of r of s is equal to 1. Next, the Ferrand frame tangent, normal and binormal vector. The Ferrand frame forms a moving coordinate system along a space curve. The tangent vector t is equal to r of s divided by modulus r of s. Normal vector n vector is equal to t vector of s divided by modulus t vector of s. Binormal vector b vector is equal to t vector cross n vector. These three vectors form a orthonormal basis at each point along the curve with t vector pointing in the direction of motion, n vector pointing toward its center of curvature, b vector perpendicular to both t and n. What is the curvature and the torsion? The curvature measure the rate at which the tangent vector of a curve changes direction per unit of arc length. What is the torsion? Torsion measures how sharply a space curve revolves in a space. It quantifies the rate at which the curve departs from being planar. Together, curvature and torsion completely determine the shape of a space curve up to its position in space. Next one is contact between curves and surface. Contact between a curve and a surface occur at a point where the curve intersects or touches the surface order of contact. What is the first order contact? The curve touches the surface tangentially. The second order contact is the curve and the surface share the same curvature at the contact point. The third order contact, the curve and the surface share the same torsion at the contact point. Oscillating objects are the plane containing t and n vectors, the circle that best approximates the curve at a point, the sphere that has third order contact with the curves. The tangent space to a space curve is formed by the collection of all the tangent lines to the curve. What is the involvates and evaluates? Evaluate of a curve, the locus of all centers of curvature of the original curve. The evaluates tangent at any point is parallel to the normal of the original curve at the corresponding point. Involvate of a curve generated by the end of a string unwinding from the original curve. A curve can have infinitely many involvates but only one evaluate. The relationship between evaluates and evaluates is reciprocal. The evaluate of an involvate is the original curve. Inercetic equations and fundamental extents theorem. Inercetic equation describes a curve using one its curvature and torsion as a function of arc length. K is equal to k of s and tau is equal to tau of s. The fundamental extents theorem for space curve, given continuous function k of s greater than 0 and tau of s, there exists a unique space curve up to rigid motion with these functions as its curvature and torsion. The curve can be reconstructed by solving the Ferrand equation. Tau of s is equal to k of s into n of s. N of s is equal to minus k of s tau of s plus tau of s into b of s. B of s is equal to minus tau of s into n of s. Helices are a spherical space curve where both curvature and torsions are constant. Helices have constant ratio of torsion to curvature. Circular helices wind around the cylinder with a constant pitch. What is the definition and properties of surface? A surface in three-dimensional space can be defined parametrically as r of u comma v is equal to x of u comma v into I vector plus y of u comma v into j vector plus z of u comma v into k vector, where u comma v are parametric in some domain D. What is the key surface types? Surface of revolution generate the rotation curve around an axis parametrization. R of u comma v equal to f of u cos v, f of u into sin v, j of u. Helicoids generate by rotating and simultaneously translation a line parameterization. R of u comma v is equal to u cos v, u sin v, cv, where c is a constant. Curves and surface. Parametric curves on a surface u of t, v of t mapped through u comma v. Coordinate curves obtained by holding one parameter constant. Geometry curves of minimum length between 2 points on a surface. Metric and anesthetic properties of surface. Direction coefficients describe the direction of a curve on a space. Isometric corresponding to surface are isometric if there exists a mapping between them that preserves arc length. Isometric surfaces have identical first fundamental forms. Anesthetic properties that depend only on measurement made within the surface. Next, application and visualization. The applications are computer graphics, physics, engineering, and biomathematics. Then visualization techniques are Ferrand frames along curves, color maps representing curvature and torsion, geometric patterns on various surfaces. Thank you.